In our previous video lesson, we dealt on scalar products. Let's take a quick recap on that. Scalar product occurs, which is also the same thing as dot product between two vectors A and B, and the result will be the modulus of A multiplied by the modulus of B cos theta, where the angle theta is the angle between them. Similarly, we can say that is also equals to A1B1, okay, plus A2B2 plus A3B3, understanding that A is equals to A1I plus A2J plus A3K, and B is equals to B1I plus B2J plus B3K. Now, let us move on to what we call vector products. Vector products. Now, vector product is also called cross product. Understanding that it is called cross product because it is A cross B. It's called dot product because it is A dot B. Is equal, the modulus of this vector is equals to modulus A modulus B multiplied by sine theta. Now, the vector product between A and B itself, okay, that's A cross B, is equals to determining a 3 by 3 matrix of this cross product. So we have these two vectors A and B. So we just write the components of A, that's A1, A2 and A3, A1, A2 and A3. We write the component of B, B1, B2 and B3, B2 and B3. And with this done, we simplify this using determinants of a 3 by 3 matrix. Now you can refer to our lesson video on matrix, where we dealt with the determinants of a 3 by 3 matrix. So we understand that we will have positive, negative, positive, and we are simplifying using the first rule. Okay, so if we are simplifying using the first rule, we will have positive I. We have reduced the 3 by 3 matrix, we reduce it to a 2 by 2 matrix, where we will have to nullify the row and the column, and we'll be left with A2, A3, B2, B3. So we'll have A2, A3, B2, B3. And then we move on to the next column as minus J. So with that, we'll also cross the row and column, and we'll be left with A1, A3, B1, B3. So we have A1, A3 and B1, B3. And finally, positive K. Okay, and we'll cross row and column. We're left with A1, A2, B1, B2. Okay, that's A1, A2 and B1, B2. Now we have been able to reduce this 3 by 3 matrix to a 2 by 2 matrix. So we understand that the determinant of a 2 by 2 matrix, if we have A, B, C, D, the determinant here will be AD minus BC. So if you apply this principle, okay, to this place, to this line, we will have that this will be positive I leading diagonal as A2, B3 minus the following diagonal B2, A3 minus J leading diagonal of A1, B3 minus B1, A3 plus K leading diagonal of A1, B2 minus B1, A2. So this will be the expression for A cross B. So let's rewrite this using the red pen. A cross B, and we are reading the terms A2, B3 minus B2, A3 I minus A1, B3 minus b1 a3 j plus k into a1, I'll put the k in front, a1 b2 minus b1 a2 k. Now this is an expression for a cross b, and we understand that the modulus of this, okay, is also known as modulus of a, modulus of b, sine the angle between them. Now we'll find out something interesting in vector products compared to dot product or scalar product. We realize that we'll have unit vectors I, j, and k in cross products. This shows that the result of the cross product or vector product of vector, okay, which is also called cross product, is a vector quantity. Okay, and we recall in our last lesson that we said that the result of, when we're dealing with scalar products, the result of the scalar product is a scalar quantity. So it's visible in the name. Scalar product gives us a scalar quantity, vector product gives us a vector quantity. So now let's take examples of vector products in the next lesson video.